G'day viewers, and welcome back to the channel. I trust you have got yourself a coffee for today's episode of My First Coffee. Some subscribers of this channel may have noticed in the past month I have been posting some questions to the Advanced Steel user groups in relation to welding symbol standards. Now, Advanced Steel is Autodesk's tool for steel detailing, so you would expect it to have a highly accurate and functional welding symbol. If you were like me to make that assumption, you will be somewhat disappointed. Now, I can appreciate that welding symbols can be a complex topic, particularly once you start moving beyond the basic welds and begin trying to accommodate the nuances for every country around the world. In the course of my research, I have examined a variety of welding symbol standards and discovered that even though the symbols are very similar in nature, it is common for those in the industry, and even those from the same region, have different interpretations of how to define welding symbols and how to represent those symbols on drawings. I feel as though that this is one of those areas of the steel detailing sector where the knowledge and industry standards have slowly been in decline over the past few decades. The three main standards that I've been using as my reference to rebuild my DFAUS welding symbol standards are the international standards, so the ISO 2553, which is from 2021 and version 9, the Australian standard, which is 1101.3, which is from 2005 and reviewed in 2018, and the Australian Steel Detailers Handbook, which is the second edition from 2019. Coming from a metric background, I only have a very basic understanding of the American standard, AWS D1.1 from 2020. If the cost of the American standards are anything like the ISO and Australian standards, I'll probably need to sell another kidney just to purchase the American standard. The cost to access standards is, in my opinion, one of those reasons I believe the steel detailing industry knowledge of standards is being eroded. The cost to access standards has just become absurd. If anyone has a copy of their local welding symbol standards in English that they would be open to sharing, I'd be keen to read up on other countries and their standards and how they define welding symbols. So, what can be done, I hear you ask? Well, all is not lost. Although the out-of-the-box Advanced Steel macro is unusable, in my opinion, for any country, it can, however, be fixed to at least perform some basic functions. Let me show you what I mean by firstly taking a look at Autodesk's out-of-the-box welding symbol functionality. Alright, so let's have a look at the out-of-the-box Advanced Steel, Autodesk's symbol. So I've got three monitors going. We've got our main monitor here, which I run Advanced Steel on. I've got my left monitor, which I have my management tools dialog box on, and on my third monitor I'm running the Internet Explorer. So you can see there's some stuff from Autodesk there. Okay, so let's look at camera 2, or main monitor. So, all right, we've got a couple of beams here, and we've got a few welds. So the first thing I want to do is look at the out-of-the-box symbol. So what I need to do is go to my defaults, and we'll use our filter down the bottom to find our weld symbol. So here you can see that I've got my custom weld symbol, so we'll just get rid of the start of that, which is using the weld template.dwg file, which is the out of the box symbol. Save that. Now to get this to work, we have to shut down Advanced Steel and reboot it so it reloads the macro. So we've shut it down. We will now reopen Advanced Steel. Okay, just open up our model browser. Okay, so I'll just check to see we don't have any drawings, and if we do, we'll delete any drawings that I've created previously. So yeah, we've got a couple of drawings there, we'll just delete those. Okay, let's have a look at this weld that we've put in here to join these. I've got 4 beams, so I've got 4 beams here, and I've put a couple of different welds on here. So let's have a look at this one. So we've got a fillet weld, and what I've done here to help understand where these parameters are showing up in the out of the box macro, or sorry, the welding symbol, I've just used some numbers. So we've numbered these parameters 2, 3, 4, 5. So you go down here to 9. On the double welds 10, 11, down to 15, and then additional data we've got 16. So we've numbered those parameters so we can see where they show up in the macro. So let's now create some drawings. So we'll come in here and run an assembly. So we've got some stick assemblies here, and we'll just run this process to produce some drawings. So it's just running those drawings, and we can open up our assembly detail, and if I zoom in here, we can now see we've got these numbers. So you can see we've got a weld, it's white. What have we got here? If we look at some numbers, I can't even find out where some of these things are showing up. So we've got numbers 3 and 4. Oh, here we go. We've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So that's where all the numbers are showing up. Oh, the reason why I don't have a 1 is because I use a 1 in my default setting to show no weld. Some people use a 6 for a 6mm to so a 6mm doesn't actually show up, but there's another story behind that. So if we look at that, we can see how those numbers are showing up. Let's go back to our welds and put in some more realistic numbers to then have a better idea of how that would actually show up if you use these numbers. So a weld thickness for a fillet weld, 6 would be a normal weld length of 50, a pitch for weld of 400, our groove text angle, so we'll put in there 30 degrees. It's a shop weld. A root opening, let's put in 2mm for a root effective throat. Let's put in there, let's go 7. Preparation depth, 8. Let's just put those in as 0. Prefix, we'll put an S. Weld thickness, we'll go back to 6. Distance from upper is 0. Root opening of 2. We'll put zeros in here again, and we will put in non-destructive testing. Okay, so now we have that update. We can go back to our drawing and update our detail. And you can see that using the out-of-the-box macro with its the block that is used to create the weld symbol, it's really not useful. Like, there's numbers here, but it doesn't match any standard, and it's really difficult to understand what it's actually telling you. Like, if you've got numbers that if you've got numbers in this weld symbol, it's just not you can't find it. You don't know what anything means. Like, if you've got these 2 and 12, like, it's not very helpful. So what can we do to improve this, or what have we done to make this more usable? Well, we've spent quite a bit of time looking at how this works, or how this macro works, to try to find a way to get the most out of what it can do. Although we can't get everything to work to all the standards, we get somewhere much closer than certainly out of the box. So let's have a look at that. So the first thing we'll do is we'll get rid of these. We'll get rid of these drawings. So we'll close that down, and we'll delete these drawings. Okay. Management tools. So we've got management tools. So we'll just come back to our management tools again, which is on our other screen. We'll come into our defaults. We'll look up again the weld symbols. Here we go. We have out of the box naming. We'll just add our customized file name in here, and we'll save that. You might as well close it down. Come back to our main screen, and we'll just shut down Advanced Steel and we'll reboot him. See, we've got our custom country settings here. Hit OK. We'll open up our test file again. Righty-ho. So let's have a look at this weld. So we've got some weld information here. Right, now we've got our new custom macro symbol loaded. Let's see what happens when we create drawings now with that. So we'll go to our output again, run our process. So we'll run a process for our stick welds, or stick assemblies I should say. So it's just creating those two drawings. We'll look at this one again. So it's the same file, but you can see it's starting to look different. Let's just open up the other beam, have a look at it. So you can see there's a different weld here. So let's go back to our weld. This is on our first beam. Let's just change some of these settings. So let's have let's go with something a little bit different we added in. So we added in a partial penetration weld. So let me just find that one. I've lost it. Where have I put it? Oh, here we go. A broad-faced bevel weld. Let's just put a number so we can see that it's different. 10. Let's just not going to have a stitch weld here. Let's get rid of some of that stitch welding information. The text for the groove is, let's make it we'll make it 45 just to show a different value. It's a shop weld. Let's show some other information here. We will put in that it's a convex, and the weld preparation here for a groove weld. So we'll go groove weld, and it's a machine finish. A root gap of 2. These values we can't actually use. These are some of the values that we can't actually get to work. We'll delete that. Weld double, so we'll keep that as a fillet weld. We'll keep it as we'll make it a 4 mil. We don't have any groove angle for a fillet weld, so that's not required. Distance from upper we don't use either. I can't get that parameter to work. The shape, let's do a flat. The weld preparation, so let's put in a grind flush. We'll put in there a root gap of 2 so we can see that it's in there, and we can save that. So now we've got that those changes to that weld. We can go back to our drawing and we can update the detail, and you can see now that we have our fillet weld with 4 that has been ground flush with a 2 mil root gap, and on the other side we have a 10 mil partial broad-faced bevel weld with a convex with a root gap of 2, a 45-degree angle of the, not that you would probably use that for that particular weld, but a 45-degree angle, and it has been machine finished. And we've also got our circle here to say that it is welded all round. Now, I think we could agree that this particular weld is a lot more presentable and a much closer to both the ISO standard and also the Australian standard. So although we can't get exactly what the standards are asking for, it certainly has a lot more functionality than the out-of-the-box solution. So there are some things that we would like to see added to that macro to make it more usable. It's close, but it's still not 100% right. So if you need to go to add those really specific welds in to match the standards, you're not going to get it with the out-of-the-box symbol. The only way you could do that is to create your own macro or your own dynamic block, which is not ideal because you have to then manually edit that in. Because we can add welds in. If we want to add a weld symbol, we can add a weld symbol in here. Let's go again. Let's put a fillet side on this one side. 6. Let's put a stitch weld in here. Let's put in a a 50 weld at a pitch of 300. We won't have a groove angle here, but we will have flat. We'll put a stagger in here, root gap 2. On the other side, we will put a, what do we want to put in there? A V butt weld. Convex, root gap of 2. Let's put our angle in here, so we'll put in there an angle of 30 degrees. Our preparation, we can have, let's just go grind. There you go. Oh, sorry, if I go back and edit that again, I actually want to put in here that we are a site weld, so we've got a little site weld symbol and continuous as well. So there you have it. You can see how the functionality that we've been able to achieve took a lot of work, but I think we can agree that that's a hell of a lot closer to the standards than the out-of-the-box solution. Let's go back here, let's have try this other weld here. We've got a backing bar here, let's put that in there. So what we do with backing bars is if we use a weld thickness of 1, that will allow it a value not to show up, because 1 is our default weld that doesn't show up. We won't put it there. We won't have we'll put a groove angle in there. Let's go. We'll do a double V, so we'll go 90 degrees. It'll be in the shop, continuous. We're going to go flat. Oh, we don't need that. So for this side, we'll go to 2. We'll go a V butt weld thickness of 10. Actually, we got that wrong. That should be 0 for that side of the weld. 90. Leave it flat, and we'll grind that flush. Root opening at 2. That's supposed to be 0. And we'll leave the non-destructive testing in there. Alright, let's have a look at how this one will come out. So we'll just update that detail. There we go. So we've got our backing bar. So I've put in there 0, so we don't want that actually. So we want to come back. That's there. That up again, we'll just update that detail. There we go. So we see we've got our material, so that material is to stay. So we've got both that. So if we just come back here, I'll show a different type. So backing bar permanent, which is what the M stands for. Backing bar removed. We'll just go and show how that works. So we'll come back into our update our detail. Oh, I think I got something wrong there. What did I get wrong there? Shop weld, that's correct. Bar removed. V butt weld. Update the detail. And my weld has disappeared. Interesting. Let's just close that down. Close that down. I'll try to recreate those drawings to see if that has caused the issue. Recreate those drawings. Interesting. I wonder what I've done. Here you go. I'd say I've got something wrong with my block, so I'll need to do some editing to fix that up by the looks of it. Yes, so there we have it. So that's with the back image. I'll have to go look in to see why that that other one is not working. So yes, so that that is a look into our updated and revised welding symbol macro. Not perfect, but it's much closer than the out-of-the-box macro. So customizing the advanced steel symbol to perform the most basic welding symbol representation has been my starting point. For the most part, this symbol customization would be enough for some to meet their clients' expectations. For others, that would need to go deeper into defining specific welding specifications. The only real viable option is to create a fully customized macro. Unfortunately, this would require manual insertion of weld symbols and management on the workshop drawings. This is not really ideal, as here at DFAUS we have built our advanced steel system to be as automated as possible by reducing any manual inputs. If you found this video helpful, be sure to subscribe and hit the like button. That's all for today's video. So with that, always remember, if your job's worth doing, it's worth doing right.